We will now proceed with the next section, which is about data types and expressions. We must take note that the following are not the same number. If we will recall, the first one is of type integer, while the other one is of type double. A whole number such as 2 is integer, and the moment that we include a decimal part, that is now of type double. Numbers of type int are stored as exact values. On the other hand, numbers of type double may be stored as approximate values due to limitations on number of significant digits that can be represented. So how do we write integer constants? The type integer does not contain decimal points such as this one. On the other hand, double constants can be written in the following ways. In its simple form, it must include a decimal point, such as this one. This can also be written in scientific notation, such as this. Although, this is not really desirable if we would like to make our program's output readable to the user. We also have other number types in C++. And of course, each number type will have different memory requirements, which means the bigger is the range of a numeric data type, the bigger is the memory requirement to store its value. For instance, more precision requires more bytes of memory. Also, very large numbers would require more bytes of memory. Same is applicable to very small numbers. For instance, we have the following. This is just an example of the data types that we use, and of course, the amount of memory that they would require whenever we declare a variable of such data type. For instance, for the short integer, it would require 2 bytes, given the following range. When we say range, this refers to the minimum and maximum value that a given data type can hold. On the other hand, the following is the memory requirements for an integer data type, as well as its range. Next, let's talk about more of the integer data type. We also have the following variation. As we can see here, we have the long integer, which is usually 4 bytes long. This is how we declare a long integer. In the case of short, the short integer would only require 2 bytes. To declare that, we can do the following. We also have the floating point data type. Because of its high precision, this would often require 10 bytes of memory. When we declare floating point numbers, it can have up to 19 significant digits. To declare that, we can do the following as an example. In the case of the float data type, it would often require 4 bytes of memory. To do that, we can do the following example. We also have the type char or character. It's because C++ program would also need to process character inputs as well as character output. Char is short for the character data type. It can be any single character from the keyboard, which means it can be a letter, it can be a number, or it can be a special character. To declare a variable with this type, we can simply do the following. The char keyword followed by our variable name. Aside from numeric constants, we can also use character constants. In this case, if we would like to use a character constant, we can simply enclose a character in single quotes such as this one. Then we can assign it to a variable of the same type, which is character. Strings of characters, even if only one character, should also be enclosed in double quotes, which means enclosing a character in double quotes is different from enclosing this character in single quotes. So how do we read character data into our C++ program? When reading character into our program, it should be noted that cin skips blanks and line breaks while looking for data. For instance, the following reads two characters but skips any space that might be between. Actually, we have seen a similar example from the previous slides. In this case, this statement requires two input in the same cin statement. If we are going to provide an input to this, we simply input each character and of course separated by a space. All the space that are included in our input will be skipped by the cin until such time that we press the enter key. For instance, if we would like to input the two characters, we simply separate them with spaces. And of course, the cin statement would simply ignore or skip those spaces. Results are also the same if the data is not separated by spaces. It is because the character data type will only read a single character. Here's an example. For instance, we declared the following character variables. Next, our program requires us to input a character that will be stored in these variables, symbol 1 and symbol 2. Then, what will happen next is that we are going to output whatever was provided in the input. In this case, without spaces, and the other one is with a space. If we are going to run this program, this is how it would look like. Next, we also have the type bool, or short for boolean. Boolean values can only store values that are either true or false. To declare a variable of type boolean, we can do the following. First, we write the bool keyword, then followed by a variable name. In C++, we also have to consider type compatibilities. In general, we store values in variables of the same type. However, there are also instances in which our variables might have different data types, but they can also store other data types as long as they are compatible with it. In this example, this can be considered a mismatch. First, we declare a variable of type integer. However, in this case, we assigned a value of type double to our variable. If the compiler would allow this, the int variable will most likely contain the value 2 and not 2.99. As you can see, this will not be rounded off. Instead, only the whole number portion will be assigned. Thus, if we are working with integer and double numbers, it should be noted that variables of type double should not be assigned to variables of type integer, such as this one. Therefore, if we would like to assign a double value to a variable, it should also be assigned to the same data type. However, if we are going to do this, even if our compiler would allow, we cannot expect that the same value would be stored in an integer variable. Next, integer values can be normally stored in variables of type double. As you can see here, we declared a variable of type double, then we use it to store a value of type integer. Thus, what will happen is that the double variable will contain the value 2.0. How about when we are working with character and integers? The following actions are possible but generally not recommended. As you can see here, it is actually possible to store character values in integer variables. Thus, the value will contain an integer which represents a, which is still a number. It is also possible to store integer values in character variables, such as this one. How about when we are working with Boolean and integers? The following actions are possible but are generally not recommended. Values of type Boolean can be assigned to integer variables. In this case, true will be stored as 1, while false will be stored as 0. Values of type integer can be assigned to Boolean variables. Any non-zero integer, on the other hand, will be stored as true. Also, 0 is stored as false. In C++, arithmetic is performed with the following operators. For example, we can do the following. Arithmetic operators can be used with any numeric type. An operand is a number or variable used by the operator, and the result of an operator depends on the types of operands. If both operands are integer, the result is also integer. If one or both operands are double, the result would be double. How about when we are dividing numbers, especially those of type double? Division with at least one operator of type double produces the expected results. For instance, we have the following example. All of them are of type double. Thus, the variable quotient would have the following value. Result is the same if either dividend or divisor is of type integer. How about division of integers? We must be careful when we are dividing integers, especially with the division operator, and in this case, a division between integer would produce an integer result. For instance, we have the following. We declared the same variables, but this time we use the type integer. Thus, if we are going to perform division, the variable quotient would have a value of 1 and not 1.66. As you will notice, the result was not rounded off. Instead, the decimal part was discarded. How about integer remainders? How do we deal with that in C++? We use the following operator. The modulo operator gives the remainder from integer division. For instance, we have the same set of variables, and this time we perform the modulo operator. The value of the remainder is, of course, 2. Next, how about arithmetic expressions? We use spacing to make expressions readable, such as this one. Precedence rules for operators are the same as used in our algebra. Thus, we use the same concept when we are performing arithmetic expression in C++. For instance, we have the following. When we are dealing with complex operations in C++, it is very useful to group our operands by the use of parentheses, such as this one. If we are going to have the following mathematical formula, we can have its C++ equivalent with the following expressions. Take note that it is important to use parentheses to separate each operand given a certain expression. Next, we also have what we call operator shorthand in C++. There are times that some expressions occur so often that C++ contains the shorthand operators for them. All arithmetic operators can be used this way. For instance, we have the following. This operation, which is quite long, can be shortened using operator shorthand. Thus, we can do the following and still have the same result. For multiplication, we can use the following. For division, and also for the modulo operator.